In this experiment, you will be investigating oscillating systems using a mass on a spring. You will be given a spring on a stand, and some masses with a carrier. An ultrasound motion detector is positioned on the floor, inside a protective cover. The motion detector emits ultrasonic waves, which are then reflected from the mass, and detected again. The distance to the mass can be found from the time delay between the emitted and detected sound. It is the same principle as used by bats for echolocation. The ultrasound detector works better when there is a wide surface for the waves to reflect from, so a cardboard square is stuck to the bottom of the mass carrier to increase the target size. The ultrasound detector is connected to a computer running Logger Pro 3 software. This software will enable you to collect data and plot displacement, velocity and acceleration over time. The first part of the experiment tests Hooke's law for a spring, and measures your spring's spring constant. Adding more and more masses to the carrier increases the force, which extends the spring. If Hooke's law holds, then the force should be directly proportional to the extension. So a graph of force against extension will be a straight line. The slope of that line is the proportionality constant. The spring constant. You will verify this measurement of the spring constant, using the relationship between the period of oscillation of a spring, and the mass of the load. If you measure the period, and the mass, then you can calculate the spring constant. Using Logger Pro 3, you will measure the time for a certain number of cycles of oscillation for a particular mass. You will then calculate the period, the time for one cycle of oscillation. This is done for several different masses, enabling you to create a plot of period against mass. This is not expected to be a straight line plot because it is a square root relation. A graph of t squared against mass will be a straight line plot, and you can use the slope to determine the spring constant. Lastly, you will look at the motion of the mass as it oscillates. You will plot graphs of the displacement, velocity, and acceleration using Logger Pro 3, and use values from these graphs to determine the maximum displacement, maximum velocity, and maximum acceleration of the mass. Using these results you will be able to test if energy has been conserved in the system.